Hey everyone, it's Mr. Rosen here. This quick demo here, I want to show you how you can compare earthquakes using exponents. Okay, so how can you compare earthquakes using exponents? So one thing about earthquakes is that they use something called the Richter scale. And the Richter scale, the way it basically works, Richter scale, is it's basically a base 10 exponential scale. So for example, they'll say, if you've got an earthquake of magnitude, let's say 3, for example, if it's magnitude 3, then this thing, it might do like minor damage, for example. Damage. And if you had something major, like an 8.5, for example, this would be like total devastation. Okay, so the bigger the number, the more intense the earthquake is. And essentially the way it works is that it's all in factors of 10. So if you've got an earthquake that's a 3, okay, if you compared it to an earthquake that's a 4, what happens is this is a scale of times 10. So the one that's the 4, this is 10 times more powerful. 10 times more powerful than the 3. Okay, so like I said, if you get earthquakes common, right, and your typical earthquake is going to be a Richter scale 3. If hypothetically tomorrow you got a Richter scale 4, that one would be 10 times more powerful than the previous one. If the next day you got a 5, it'd be 10 times more powerful than the 4 even. Okay? Now how does that relate to exponents? So let me give you an example. So how much bigger or how much more intense is a earthquake with magnitude 7 compared to one with a magnitude of 4. Okay? So how would you compare these two earthquakes? Obviously we know the one that with the 7 is much worse. With the 7, that's a major earthquake, whereas a 4, you're going to feel that, but it's not going to be massive. Okay? So the way we compare them is we divide them, and we're going to put the larger one on the top. So it's a scale of 10s. So this is going to be a 10 to the 7 divided by a 10 to the 4. And the way our exponent rules work is we've got two bases that are the same, and we're dividing our exponents. If we're dividing exponents, then we can subtract them. So it becomes 10 to the 7 minus 4, which gives us 10 to the 3. Now 10 to the 3 you can work on your calculator. That is 1,000. 1,000. Okay? So what does this mean in comparison to our earthquake here? It means that the one with the 7, the magnitude 7, is 1,000 times bigger than the one with the 4. So the mag 7 is 1,000 times stronger than the mag 4, the magnitude 4. And again, if you really weren't sure about it, what you could do is you could sort of write it like a number line here. Okay? So if to get to a 4 to the 5, that's times 10. Get to the 5 to the 6, that's another times 10. 6 to the 7 is another times 10. And if you've got 10 times 10 times 10, that's going to be 10 cubed. Okay? So that's a little demonstration about how you can compare earthquakes and how you can use exponent laws to solve earthquake type questions. And I'll do one more. Let's do a really, really major earthquake here. So let's say we got an earthquake with a magnitude, just one more practice, magnitude 9. This is just a massive, massive earthquake. It'd be brutal if you ever experienced a magnitude 9. And let's compare that to magnitude 4. To magnitude. So again, a 4 is pretty minor. A 9 is just unbelievable. It's not comprehensible even. So how do we compare these two? So we would put the 10 to the 9, and we would divide that by 10 to the 4, which is going to give us 10 to the 9 minus 4, which gives us 10 to the 5. Okay? So when you divide exponents, you subtract them, as long as they have the same base. Now 10 to the 5, that is, I believe that's one more zero we need. 10 to the 5 is 100,000. Okay? So the Richter 9, or the magnitude 9, is 100,000 times stronger than the magnitude 4. Okay? So that's how you can use, like I said, exponents to sort of calculate the intensity. And it works even for decimals as well. So you can have earthquakes, for example, one last one. So let's say we have 10 to the, 4.1 divided by 10 to the 2.9. Okay. We can actually do this division as well. And you would just need your calculator to actually calculate this one, because we are going to use our exponent button. So this would be 10, where are we here? 4.1 minus 2.9. This would be 10 to the 1.2. And this number here would be 15.8. And you just use your exponent button in your calculator to solve that. So that means the 4.1 earthquake is 15.8 times stronger than the 2.9 earthquake. Okay? So hopefully you learned something in this video, and hopefully you learned a little bit about exponents and earthquakes and how you can compare them by dividing and subtracting the exponents.